Hello everyone, I'm building ChordTune, a mobile application where heart rate data gets turned into music for performance enhancement. I'll guide you through what I did in week 3 and 4. Let's start with the PowerPoint presentation I made. It's still a school project, so in week 3 I needed to show my project in a presentation. This is a presentation I made. I explained I'm making a mobile application where biometric data such as heart rate get turned into audio for performance enhancement. I went to the peer-reviewed paper studies I showed you in the last video. The research I did, all about the vagal tone and the frequencies. Here I did some more research about which frequencies and which beats per minute and decibels are helping the nervous system regulate better. I did some research about the audio engine, of course. I asked some questions on Reddit because I didn't know for sure what to use best, and they answered pretty well on that. I showed them ChordTune was born. ChordTune, of course, you already know is the name of my application. I did a quick explanation about ChordTune. Core for Cortex Core and Tune, of course, for music. I thank them for listening and I thank you for watching. This is not the end of the video, but I do thank you for watching. Let's go to the next thing. I went through applications from competitors to see the page flow they are using and how they set up their page flow initially when you start the app for the first time. Of course, we don't want to land on the login page or register page at the first time opening the app. We'd like always to have some explanation about what the app is doing. Endel, this is very good. This is also an app that lets you sleep better with personalized sounds and meditation exercises, etc. So I will be doing something like this with my app, of course, that I will be guiding them through some explanation about what the app is doing. And then after that, we go to the login page. I also looked at when and how they ask for the paywall. So of course, they all do it on a different way and with more minimalistic style or less. So I analyzed this so I can implement this myself later for my own project. I also switched to a build environment. Expo didn't do the job anymore since I'm using the React Native Audio API. It's not supported for Expo, so I switched to a development build. This takes a bit longer, but it loads up the emulator just fine and it does the job, so I'm not really too bothered by that. Since I haven't really used an audio API before, or I'm not really familiar with music in general and the manipulation of it, I read a bit of the React Native Audio API to see how it works and what you can all do with it. I think the documentation is pretty clear and I really like this documentation and this package. The possibilities with it are pretty big and they perfectly fit for the project I am building. So I'm glad I can use this package. Unfortunately, when switching to the dev build, I came upon an error, which didn't really state anything too clear, but after figuring out what it was, I came to the conclusion it was because of my protected routes. My protected routes I set up in last video were not compatible for React Native Expo. Having a simple use effect to see whether the user is logged in or not, and whether it's logged in or not, redirecting it to the login or registered page, was the simple and easiest thing I can do. It protects all the other pages. This way I don't need to redundantly wrap components with the protected routes. They can just go to the login page if they're not logged in, which is safe enough. Here, as showed before, I have 3 zones: the activation zone, sustain zone, and recovery zone. And in each zone I have 3 statuses. So I have when the heart rate is too low, when it's optimal, and when it's too high. I call these moods, so each zone has a state of the heart rate. I call this a mood, so I have 9 moods in total. I transferred these tables from Notion to actual code by making an audio preset TypeScript file. This structure looks a bit like a JSON file. As you can see here, we have 3 times the zone we are in and the status in that zone. So what I did is for each status in the zone, so each mood, I created a preset which has some information about like the name, a description, the loop URLs, which I'll show next, and the BPM of the track, or what it's supposed to be like. So you see loop URLs, I have not linked them yet, but I will do this later. So each mood has multiple loop URLs. These are 30-second loops which I created that will eventually be used in each mood the user is running in. So when he's running for, let's say, in the activation zone and his heart rate is too low, the loops in here will be played and will be manipulated later on with the React Native Audio API. In next video, I will be displaying the loops and how they sound. This is because next week and the week after that, I will be completely focusing myself on the audio part of the development for this project. Stay tuned till then. This file is very important because it defines which heart rate zone the user is running in. So recovery, sustained, and activation. It personalizes the zones based on age and fitness level, ensuring more accurate zones definitions for each user. It uses a 15-second sliding window, which uses smoothing. This reduces fluctuations, making sure not every second there is a zone defined. If this was the case, the readings would be less stable. The classify heart rate function determines the current heart rate zone and intensity state, with optimal smoothing for more stable readings. This loop checks which heart rate zone the current intensity falls into and then classifies it as too low, optimal, or too high based on whether it's in the bottom 25%, middle 50%, or top 25% of the zone range. The get personalized zones calculates personalized heart rate zone limits based on the user's max and resting heart rates, adjusted for age and fitness level. So when we run these functions, something like this will come out of it. So we have the profile of a user and we read out the current heart rate. So with the function, we call the heart rate we currently have, and based on the profile, the zone and the state will be determined, and this way we can use a correct loop and manipulate this audio for customized audio. So if we run the function based on the current heart rate and the user's profile, we get the output of the zone he is in and the state he is in, and based on this we can deliver a customized loop and manipulate this audio for what the user needs for a precise audio output. Next week I will be making the loops, building the audio engine, and making sure the audio will be manipulated based on what the user actually needs. Thank you for watching to this video, and I wish you a very peaceful and nice day. Bye bye.